Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. This is video number 3 guys, and I'm doing question 4 from the November 2022 examination, which was written by the learners registered under the Independent Examination Board. Please note that guys, there are already 2 videos being uploaded, and there will be 5 videos after this one. You can just click the link on the description, uh, download the question paper, and then answer the questions with me. Inside the link, guys, in the description, you'll find a playlist with the full memorandum. You can just watch from video number 1 until the last video. If there are things I'm not sure about, guys, please do ask on the comment section. I'll definitely come and assist you. Okay, question 4. Ne? Firstly, we are given the graph of f and the graph of g. The first thing they want us to find is the period of f. F is equal to sine 3x. Remember that, guys, a period is always 360 all over the coefficient of x, and our coefficient is what is 3, so the period is just 120 degrees. This thing simply means that, guys, the full wave for our graph will end at 120. If a full wave is when our graph have your 2 turning points, né? So that's a full wave for the graph of f of x, and it ended at 120 degrees. So we have 120 degrees as our x value there. Are you together? And then B, you are supposed to determine the range of the graph of g. How can you determine the range of the graph of g? I know that the maximum value for the graph of g is here, and the y value is 1. The lowest y value, I don't know the lowest y value within that restriction, né? But I can calculate the lowest y value. How can I do so? I know that the graph of g of x is equal to cos of x minus 30 degrees. I do know the x value is 180. I just want to find out the corresponding y value when x is 180. This thing will give me a negative cos 30, which is just negative root 3 over 2. So the points there, let's call that point P. I have 180 degrees and negative root 3 over 2. So the range for the graph of g, I now know that the graph of g will be just in between negative root 3 over 2 and 1, within that restriction there. Okay, I'm supposed to show on the graph using capital letters the values of x for the solution whereby f of x is equal to g of x. I'm supposed to indicate by just using capital letters. Okay, that will be point A and this will be point B, because that's where our two graphs intersect or touch one another. Now I'm supposed to show using the graph. I'm supposed to use the graph rather to determine the values of x for which the graph of g is above the graph of x. Greater means the graph of g is above the graph of x, né? And I can only see that. Oh yeah. If I can check here, the graph of g is above the graph of x, and then here both of the graphs are equal, and still the graph of g is above the graph of x over here. Are you together? So this only happens when x is between 0 and 120. When x is between 0 and 120, the graph of g is above the graph of f, yes. That's how, guys, we would have tackled question 4. It was a short question, and I really hope that, guys, you did ace it.